Imagine opening a class in your code and you immediately notice everything is somehow connected to everything else. Nothing really belongs together and every change turns into a nightmare. That's exactly what a metric makes visible: lack of cohesion in methods, or LCOM for short. And that's what this video is all about: how LCOM works, why it matters, and how you can use it to build better software. My name is Tobias Löser and I'm a trainer and consultant for software engineering with a focus on architecture, quality, and agility. And these three topics are closely linked to cohesion and coupling. Because if we understand how strongly methods within a class really belong together or don't, we can significantly improve the quality and maintainability of our systems. So let's dive right in. Before we take a closer look at LCOM, we need to clarify two fundamental terms: cohesion and coupling. Cohesion describes how strongly the parts of a unit, for example the methods or for class, belong together. You might know the term cohesion from physics or chemistry. It's about the binding force similar to glue. So how strongly does everything stick together here? High cohesion means, for example, everything in a class works together toward a clearly defined goal. Low cohesion, on the other hand, would mean the methods are in the same class more or less by chance, but have hardly anything to do with each other. The binding force is actually weak. Coupling, by contrast, describes how strongly one unit depends on another unit. Think of a train. The individual cars are coupled to each other and thus depend on one another. High coupling between software modules could mean if you change something in one place, it can have unexpected effects in many other places. Low coupling means modules or classes are largely independent of each other and are therefore easier to understand and maintain. You could also say cohesion looks inward. How strongly do the methods or of a class belong together? Coupling looks outward. How strongly do modules depend on each other? To avoid having to analyze a large piece of software right now, let's take a small everyday example. Imagine we have a shelf with tools in our garage. If I have a cordless drill and 20 matching bits in one compartment, then cohesion is high because the elements in that compartment belong together and all pursue the same goal. But if the cordless drill, the jigsaw, and my old MP3 player are lying there, cohesion is pretty low. What about coupling? In the first case, I have the matching bits right in the same compartment. For my use case, I don't need to look at other compartments, so coupling is low. In the second case, my bits are in a different compartment and there's additional coupling involved. Why do coupling and cohesion actually matter? Because high cohesion and low coupling lead to software that is easier to understand, maintain, and extend. And that's exactly where LCOM comes in. It measures cohesion and checks how strongly the methods within a class really belong together. Now let's take a closer look at what lack of cohesion methods, or LCOM, actually measures. The name already gives it away. It's about the lack of cohesion in a class. LCOM tries to make visible whether the methods of a class really belong together or whether they exist more or less independently side by side. But how can we tell if methods have something to do with each other? With LCOM, we use the attributes or instance variables of the class for this purpose. Imagine a class that contains several methods. If almost all methods work with the same attributes, cohesion is high, the class is coherent. But if many methods use completely different attributes, cohesion is low, and one might wonder why these methods are actually encapsulated in this class. And that's exactly what is reflected in a high LCOM value. Just a quick note up front, there are several definitions of LCOM. There's LCOM 2, 3, 4. They differ in the exact way they are calculated, but they all pursue the same goal: to make visible how strongly or weakly methods within a class work together. For this illustration, here's a simple example. Imagine a class person with an attribute name and the methods getName and setName. Both methods work with the same attribute name. This means we have high cohesion and low LCOM value. Now someone extends the class with a getAge method that works with different data. Now we have a method that doesn't work with the previous single attribute name. Cohesion decreases and the LCOM value increases. It's not bad yet, but we can see how we arrive at a measurement of cohesion through the attribute usage. And why should you even bother with LCOM? The answer is actually quite simple. LCOM is directly related to the quality of your software. After all, LCOM gives us insight, or at least an indication of the cohesion of a class. Classes with high cohesion are clearly structured, easier to understand, well-testable, and usually also easier to extend. Classes with low cohesion, on the other hand, are harder to maintain, error-prone, and quickly turn into what some call God classes. Back to the example about the class person. Adding the method getAge is still harmless, and maybe a few more matching attributes and methods will be added. But at some point, this class grows and we perhaps add methods for tax calculation, vacation requests, or similar. And each method either uses its own attributes or maybe none at all. The class keeps growing and eventually it's no longer really clear what the class is actually for. And every time changes are made to this class, they might not only affect the rest of the class itself, but also coupled elements that use this class. This is where LCOM comes into play. The value serves as an indicator of how high the risk is that this class will eventually no longer be properly maintainable. Of course, the value doesn't replace common sense or clean software architecture, but it is a valuable tool for recognizing these risks early. And that's where the big added value lies. LCOM makes visible what you often only notice when it's too late, namely when changes suddenly have unwanted side effects or refactorings create huge effort. This making visible is a key factor when it comes to software quality. Galileo Galilei said, "Measure what is measurable and make measurable what is not measurable." And to make quality measurable and be able to react early, we can use metrics like LCOM. Before we look at a practical example, just a quick note: if you want to dive deeper into these topics, software quality, architecture, or also agile methods, feel free to check out my trainings and consulting offerings. That's where we go into depth and work on solutions tailored directly to your projects. To make LCOM tangible, let's look at the calculation using the example of LCOM 2. The formula is LCOM 2 equals P minus Q, where P is the number of method pairs without shared attributes, and Q is the number of method pairs with at least one shared attribute. If P is lower or equal to Q, so a negative value, we set LCOM 2 directly to 0. Let's take the class person as an example with the attributes name and age, each having a getter and a setter. So getName and setName use the attribute name, and getAge and setAge use the attribute age. Now we form all possible method pairs and check in each case whether at least one attribute is used by both methods. In total, we can form 6 method pairs. GetName and setName share an attribute, namely name. GetAge and setAge share an attribute, namely age. The other 4 possible combinations use no shared attributes. P, so the number of method pairs without shared attributes, is therefore 4. Q, so the number of method pairs with shared attributes, is 2. Our LCOM, so P minus Q, or 4 minus 2, is therefore 2. That's not a high, not a bad value, but of course it could be better. If we only had the name attribute and its getter and setter, we could only form one method pair and it would have a shared attribute. P would be equal to 0 and Q would be equal to 1, which would be minus 1. So we would set our LCOM to 0. Cohesion would be optimal because all methods work with the same data and therefore obviously belong together. Now the question arises, how does LCOM actually fit into the bigger picture of software architecture and agile methods? First, from an architectural perspective, a class with high cohesion and thus low LCOM is usually easy to understand, well testable and robust to changes. That means it fulfills central quality attributes such as maintainability and extensibility. Of course, LCOM alone is not sufficient to ensure quality, but classes with low cohesion or high LCOM are already a warning sign. They often violate the single responsibility principle from the solid principles and lead to fragile architectures in the long run. I'd be happy to talk about solid sometime too. If you're interested, just let me know in the comments. But what does LCOM have to do with agile software development? Agile methods rely heavily on incremental development and quick feedback. When you deliver features in short iterations, you don't want small changes to have large side effects. That's exactly where LCOM helps. A high value shows you early on that you should plan a refactoring before the class grows uncontrollably. You could say LCOM is like an early warning system for architecture or technical debt. And that fits perfectly with the Agile principle of technical excellence, which is explicitly emphasized in the Agile Manifesto. So if you take software quality and architecture seriously in an Agile environment, it's important to use such metrics and not just occasionally in isolation, but to embed them in daily work and consider them continuously. But how can you continuously consider such metrics? How can you meaningfully measure LCOM and use it in your projects? The good news, you don't have to do the calculation manually every time. In general, there are several tools that calculate various metrics. Of course, it always depends on which programming language and framework you are using. Many development environments already have tools integrated, or there are plugins you can install. Ideally, you are already using CI/CD and simply add these metrics to the build pipeline so you get regular feedback. A tip from me, don't use LCOM as an absolute figure, but as an indicator. A high value does not automatically mean this class is bad, but it is a reason to take a closer look and ask yourself, does the class have too many responsibilities? Is the software architecture still appropriate? It's not about rigidly adhering to a specific value. The goal should be a high software quality that also ensures maintainability, extensibility, and happy software developers. Let's wrap this up briefly. Cohesion means how strongly the methods within a class belong together. LCOM measures the lack of cohesion. A high value is therefore a warning sign. A low value, on the other hand, shows the class is well structured, focused, and has a clear responsibility, so a single responsibility. The key point is, don't use LCOM in isolation, but as a kind of compass in combination with other metrics. It's not about achieving perfect values, but about keeping your architecture maintainable, extensible, and testable in the long term. If you pay attention to cohesion early in your projects, you save yourself a lot of effort later and prevent small classes from turning into large, unpredictable monsters. And now it's your turn. I'm curious, what experiences have you had with software quality and metrics like LCOM? Feel free to write about it in the comments. If my input was helpful to you, feel free to follow. I'm also happy about likes and nice comments, of course. That way I know which topics interest you most and I can prepare even more practical content for you.